All right, so today we're going to look at arc length, area of a sector, and area of a segment, which is the start of chapter 19. We just got to be really careful just with reading what they're actually asking you, because sector and segment, look, they're sort of similar, and so you just got to remember. So when they talk about an arc length, they're actually just talking about the length along the edge of the circle. So it ends up being part of the circumference that they're talking about. So when they say minor arc, it's because if the circle was broken up into two pieces, the smaller piece will be the minor arc, and then if you had a larger the larger line around the edge, that will be the major arc. So you think about it. So if you think about, if you're finding the circumference of a circle, the formula for that is actually 2 times pi times r. So some people use... That's okay. Some people use pi times d, but I'm just going to stick with the 2 times pi times r. So what happens when they want you to find an arc length? They might give you a section of the circle. So they'll give you the degrees. So say they gave you that as 130 degrees. So really what you're thinking about is, like, I've got 130 out of the full circle, which is 360. So that's what you're doing, and then you're timesing it by the formula for circumference. And the reason that they use that, and then you can see you can actually cross cancel. So 2 goes into 2 once and 2 goes into 180. And this is how they get this formula down here, so that the length of an arc can be given by this formula, where you're just doing pi times the radius times whatever angle, how much the angle. So that example I just did was 130 over 180. Okay, so it's quite simple. So if we look at this, doing this example here, and it says find the length of the arc ACB. So they're just showing you're going through that way. Okay, so if they didn't say that, because you might go backwards and go the other way. So they really want ACB is the minor arc, because it's the smaller one. Okay, so when you're trying to find it, write your formula out. So the formula for the arc is pi times the radius times the angle size over 180. So in this case, it's pi times 10 times 120 over 180. Now they're saying to 1 decimal place, so you type that into your calculator, and I've done that up here. So 1 decimal place would be 20.9 centimeters. So remember, it's a length, so just in centimeters for that one. All right, so that's arc. So now we're looking at area of a sector. Now so area of a sector. So a sector is like the piece of the cake. If you've got the circle, you're taking out a whole chunk of it. So you can see the formula there. If you had an area of the circle formula, we know that that's pi r squared. So when you only want a certain part of it, so when we're saying, all right, they'll tell you how much of a full circle you've got, and that's how you get the sector formula to be just how much of a full circle you've got times by the formula for area of a circle. So that's how we can use this. All right, so in here though, in this question down here, they've asked me to find the area of the minor sector. So the minor sector is this bit in here. So off I go, I'll do that. So area of a sector is pi r squared times the angle over 360. So then I've got pi times 10 squared times the angle, which is 120 over 360. They're saying correct to 2 decimal places. So if I go back here, I've done that. Here, pi times the radius squared times the angle over 360. And sorry, I just did Control Enter to get the decimal answer, and it said to 2 decimal places, so 104.72 centimeters squared. And it's centimeters squared because it's area now. Now, when they ask us for the major sector, they're talking about the big piece out here. And so you need to work out how many degrees that is. And if the little one's 120, then this one must be 240 degrees, because 360 minus 120 equals 240. All right. So if we go find the area of the major sector, it'll be still times the radius, pi times the radius times the bigger angle over 360, and we want to 1 decimal place, so that's been done here. So it'll be 209.4 centimeters squared. Okay, so really easy. Now, the area of a segment. So what a segment is when you've got, just so you know, you've got a part of a circle, and generally, so if you first just cut it like that, that bit is, I've cut out a sector. But then what they do is they put a line across here, and that line is a chord. So when a chord cuts the circle across from one side to the other, but it's not necessarily through the middle. Okay, so the segment that they're talking about when they're talking about area of a segment, the segment is this bit, just this bit in here, that blue bit. So, and you obviously you still have your radius of the circle. So in the end, we're going to use, this is for the segment, this is the formula that I want you to use. So segment, just mark that that's the formula. They do give another version of it, and I wish I'd rubbed that out. So in your notes, can you just erase that out? It's just confusing, and as I said, I've seen students do it. It just confuses them. So just stick with one. And I like this one because you can see. If you look, just to show you, if you look at what you had here, if I highlighted that whole bit, I would have an area of a sector. So you think if I had the area of a, so first I had a sector there, okay? Now, if I minused the area of that little triangle that's formed in here, so what I'm showing you, there's a, see how when you cut off, you get that triangle. If I minus that triangle from that sector, so the area of this triangle, so that triangle's in there, if I minus that, I end up with the segment. So you end up with just that, sorry, that little blue bit down the bottom, which would be in here. Okay, so that's the way that formula is created, because the area of a sector would be pi r squared times the angle, so whatever angle they give, over 360. And then what you're going to do is you're minusing the area of that triangle. And what they've done is they've used that sine rule for the triangle, and where you multiply the two sides you're given by a half, and then sine the angle given. Now, why is it radius squared? Because those two sides are going to be the same length. So there's that. So what I probably want you to write underneath this bit is just take note that that's the area of the triangle bit. Yeah, because sometimes what if they might ask you for that bit, and you have to be wary that that's the triangle bit. And then this start bit is obviously the area of a sector. Okay, just so you're aware. So let's go find, we can just use it It's okay if we're just finding a segment straight off, but if we're trying to work out little different parts, which often come up in harder questions, we need to be able to break up that formula. So area of a segment, I'm doing this example they've got here. So we're going to say it is pi r squared times the angle over 360 minus a half times r squared sine the angle. So in this case, it would be pi times 112 squared times 75 over 360 minus a half times 112 squared sine 75. Okay, and you'll end up with an answer, which I did here. And sorry, we don't have the exact. So we come down here and we have, I'll just round to one whole number. We get 2152 millimeters squared. So just remember, it's an area, so you'd have squared units. All right, have a look. So here's a couple of exam questions. So this was a question 8, so it's going to be quite difficult. This was part of the solutions, so I've just popped it in there so that you had this was part of the solutions, okay? So you weren't given this, you were only given this diagram here. And it said 3 circles with the radius of 50 millimeters are placed so that they touch each other. The region enclosed by the circles is shaded in the diagram. So the area of the shaded region was. So what they did is they're showing you that if you're in the center of the circle and you go to the edge, that would be the radius. And then so would this. That would be the radius. And if I went there, that'd be the radius. There to there is the radius. Here to here, radius and radius. So in the end, you can have a triangle, and because the radius is 50, they're saying 2 of them makes 100. So we've got a triangle that's all exactly the same side length. So if they're all exactly the same, that makes it an equilateral triangle. And an equilateral triangle means that the angles are all the same as well. So you now know that in there is 60. Okay, so what you can see is you've actually got 3 sectors formed there. So what I'm talking about is these are 3 sectors are getting formed inside this blue triangle. And so you can see if I found the total area of the triangle and then I minused those 3 sectors out of it. So I'm talking about if I minus those 3 sectors out, I'll just draw them like that, you're gonna end up with just that shaded bit in the middle. Sorry, a bit dodgy, but there you go. So you're gonna end up with that shaded bit in the middle. So that's what we could do. So first of all, we had to see the area of a triangle. So we have, we're going to find the area of this triangle, and we're going to minus 3 times the area of a sector, which remember is pi r squared angle over 360, and that will give us our answer. All right, so we've got an equilateral triangle. Which formula could we use? We could use Heron's formula for the triangle. So just do it up here. So Heron's, remember you need to find S first. So S is when you add up all the sides and you divide by 2 and you end up with, so that's 150. And then its formula, remember, is S minus all the sides multiplied by like that. So in the end, area will be the square root of 150 times 150 minus the sides, And you do that 3 times. So I'm going to just cheat and put cube there. But that's the same thing. So if we go and do that on our calculator, which I think I did up here. So we found S, then we put it into Heron's formula, and I get that the area of that big blue triangle is 4330. Okay, so I've found that this is 4330, and then I'm going to minus 3 times a sector, which is going to be pi times the radius. Now remember, the radius is only 50, and the angle we know is 60 over 360. Okay, so we can do all this on the calculator. So I just done that there. I found that the area of one sector is 1309. So then I would be doing 4330 minus 3 times that 1309, and I've done all that on the calculator, and I end up with 403. So there's the answer A. Okay, sorry. So that's it. So I just pop that in here because of the solutions to remind you. Okay, so we've then got this question here. The pie chart displays the results of a survey. 80% of the people agree, 20% disagree. The radius of the pie is 16 millimeters. The area of the segment represents agree in square millimeters is closest to. So normally we get given an angle amount. This one we've just been given a percentage. So the area will still be the same. Its area of a circle is pi r squared, and then you just times in by how much of the full circle you've got. So if you've got 80%, you've got 80 out of 100. So we're just going pi times, and they told me the radius was 16 squared times 80 over 100. And you end up with, if we do that on the calc, did I do that? Yep, I did that. End up with 643. Okay, so it doesn't matter if they don't give you a degree. You just say, well, they gave me a percentage, so I've got a proportion. I've got how much I've got. All right, this is another one. So this is 2019. You can see another question 8. So it's the last question, and they put 4 circles this time, and they've said the shaded area. So what you needed to do is do the same thing. Like, you can get the center of the circle and see you've got the radius. If I keep going like that, what I end up doing is I create a square. Okay, so this time I end up with a blue square, and the radius, so across here is 2 radius, and this is 2 radius, and so on. So they'd all be, that's their lengths. And you can see when you do that cut, you've got a quarter of the circle. So if you look in here, we have a quarter of the circle. So 360 divided by 4 is 90. So you've actually got that's 90 degrees in there. Okay, so if you look, we've actually got oh, that's a bad diagram. We've actually got 3, oh god, they're bad, but anyway, sectors there, haven't we? We've got, this is 1 sector, 2 sectors, 3 sectors, 4 sectors. So if you're trying to find the area of the black bit in here, we're going to say, well, that area is going to be the area of the square minus 4 times, we've got this sector here. Okay, now if you think about it, so the area of the square will be 2r times 2r, because they're the two sides, minus 4 times, now we've got if we've got 4/4, we end up with, but we can still do it. Let's just do it. It's 4 times the area of the sector, which is pi r squared over the angle over 360. So you end up with 4 pi r squared minus, and this is going to be, this will simplify down to pi r squared. Okay, sorry, we know that that's 90. All right, and you'll end up with it equaling 4 pi r squared minus pi r squared. So the answer is D. All right. This last one that I'm going to do is the windscreen wiper. So you've got a sector of the circle, and really what you're saying is they say they want the shaded region. So really what you had a big sector, and you minused a small sector, okay? And they both are 110 in there, degrees in that bit, but their radius is different. This one's radius is 39 and this one's radius is 9. Okay, so all you're going to do is area of a sector minus that. So we're going to, area of a sector is pi times the radius squared times the angle over 360 minus pi times this one's radius times the angle over 360. So if we do that on the calc, okay, so we get 1382, which is B. So that was question 7. That's easy. You'd be loving it.